Hello everyone, welcome to Coders Camp. We are at third day of November LeetCode challenge. So we have already uploaded a unique paths problem in our source channel already. So we are directly jumping on to the third day problem, sum root to leaf numbers. So here the input given here is a root of a binary tree, and we have to return the total sum of all root to leaf numbers. Test cases are generated so that the answer will fit in a 32-bit integer. So let's understand this with an example. So here is our given example in the problem statement. As per the problem statement, each root to leaf path represent a number. For example, here 4 is the root element. From 4 to every leaf it reaches, there is an integer number. So start constructing integer starting from 4. The first number would be 4, 9 and 5. So the first number is 495. And the second number is 491, and so the second number is 491. So there is one more path exists from 4 to right side of the tree, which is 40. So adding this, you would get 1026 as the values, and this is what we are going to return. So yes, this is a very simple problem if you are starting to learn any binary tree traversal, either it is BFS or DFS. It is a very good problem to start your practice with. So as we are going deep, so definitely you must have figured out which traversal algorithm to use. So we are going deep here. So we are going to use DFS algorithm to traverse this binary tree. So as simple as that, we are simply going to traverse and add the numbers and finally add the total. So let's see how we're going to do that. So as I said, we are going to perform a depth first search here. You can either go for an iterative approach or recursive approach. The easiest way is to go for the recursive approach. So it is very similar to a basic DFS traversal where we are going to call the left side and the right side from the root node recursively to traverse the nodes. So while traversing, we are going to have two variables, which is sum and total. So we are going to construct our sum one by one by adding numbers at each node starting from the root node as we traverse towards the leaf node. So starting from the very first element in the tree, which is 4, we are going to add 4 to our sum. So 4 will be added first, and then moving on to a deeper side, which is 9. So what we does is we does a multiplication with 10 plus the value of the current node, which is 9. So which means 49, because we have to construct our elements in such a way that the numbers goes in a hundreds, tens and ones position. Suppose if there are 4 nodes, then it should go like 1000, hundreds, tens and 1 position. So again, when we traverse towards the next node 5, we again gonna do into 10 plus the value to construct the number as such. So now it will be 49 into 10 plus the current node value, which is 5. So it will be 495 at the end. So once we keep constructing the number, we reach the leaf node. So there are no right or left nodes exist to this node, which means this is the leaf node. So once we reach the leaf node, which means we constructed one number to add to our result. So in this case, we are going to add that 495 to our existing total. Same way, we are going to start adding 4 and then 9 and then 5 and then 1 as the second number and construct our sum. So once we reach 1, there will be no left or right nodes exist. So 1 is the leaf node. So once we reach the leaf node, it's time to update our total with the next number. And same goes to the right side of the tree. So once we traverse through 0, we find that there is no left or right node exist, and we reach the leaf node, which means whatever we constructed so far in the variable sum will be updated to the total. And once we traversed all the nodes in the existing tree, we are going to return what is there in the total value. Yes, this is it, as simple as that. Let's see the code now. So yes, as I said, we are going for a recursive solution. So as usual, like any DFS code we do, we are going to write a helper method. So here we are going to call it recursively. So every time we are going to call the left side as well as the right side of any node. So yes, this is the basic DFS recursive code. Here we have to keep track of two variables. So one is sum and other is total. As I said, every step we are going to multiply it with 10 and add current root's value. And we are going to check if we reach the root node. So before that, let us declare a variable total, which is we are finally going to return. Then we are going to update our total. So every time we find the leaf node, we are going to update what is there in the sum to our total. And finally, let's return our total. We don't have to really return our total because we declared that as a global variable here. So here we are going to call our helper method. Starting sum will be 0 and return total. So yes, let's try this. Yes, let's submit. Yes, the solution is accepted and we have completed today's problem. And as I said, if you see, these problems have been asked exactly a year back on June LeetCode challenges. I think all of the problems we faced in the recent week has been already asked in those time. So yes, hope you understood the concept and like this video. If you like this video, hit like, subscribe and let me know in comments. Thank you.